In this video, we'll be going over the section 1.1 notes, which are on statistical and critical thinking. So first, the main theme of the semester is written out. So the main idea in the study of statistics is to be able to infer something about a large group by studying a sample taken from the larger population. And so here our goal is to become better critical thinkers. So we're going to take in data, analyze it, and then draw valid conclusions. So the first thing we're going to do is go through some vocabulary terms that are going to be important for you to know. I would recommend making flashcards of these so that when they come up in the course, you're not scrambling for your notes to see what they mean, but you actually understand what I'm saying as I'm saying it because you know what those terms are. So first, data is a collection of observations, which could be measurements, categories, or responses. Statistics is a process. It's the science of planning an experiment, obtaining data, and then analyzing and interpreting that data. The goal is to be able to draw a conclusion. All right, the next two words I want to talk about is population and sample. So population is the complete collection. The complete collection of all measurements or data that are being considered. We're going to skip this one for a second. The sample is a sub-collection. Of data selected from a population. So you might be interested in learning about high school students or college students and their mathematical success in the United States, but it is not cost efficient to be able to survey every single high school and college student in the entire United States about their math experiences. That's just not possible. And so the population, that's what we're interested in, but we would take a sample of people that fit that criteria so that we could learn about them and then make conclusions based off of that. And so that's how statistics typically works. A census, you've probably heard of. In the United States, they do them every 10 years. That's a collection of data from every member of the population. And so when they take that census every 10 years in the United States, they're trying to get to every single residence in the United States to get information about every single person that lives in the country, which is a difficult task to do. Some people don't respond to the postcards and they don't submit the information, and then people have to come around and knock on doors. It's a whole thing. So census is trying to get information about every single subject within the population, but a sample is a lot more common. All right, a voluntary response sample is a sample in which the respondents decide for themselves whether to be included. So voluntary response sample might be the easiest way to get information. An example of this would be like the course evaluations. So we ask you to grade us kind of on how the course went, and if you learned what you're supposed to learn, if the technology supported the material, if you felt like you'll retain the information, all sorts of things they might ask you. But ultimately it's your choice whether or not you fill out that course evaluation. And so because this is a voluntary response sample, it often represents extremes. So people who have a really good experience will fill these out. People who have a really bad experience will fill these out. People who have kind of a mediocre experience will not often fill this sort of response out or respond to it. And so these are not great representations of the population because they're typically in the extremes. So they're convenient, they're easier to do. You throw the questions out there to get the information, and some people respond, but they're generally not great sources of information. Okay, we're going to leave the two words that are left for a little bit later in the notes. So statistically significant and practically significant we'll cover in a little bit. So as part of the statistical study process, there are 3 parts. So the first part is to prepare, the second part is to analyze, and hold on, I have to grab the other page. And the third part is to conclude. Okay, so we're going to look at those parts in a little bit more depth. So to prepare, you're going to consider the context, which is represented by the data. You're going to consider the source of the data and the sampling method used in collecting the data, and we'll study that more at a later date. Next, you're going to analyze, you're going to graph and explore the data and apply statistical methods to obtain results about the data. And so when we look and analyze the data, we want to consider possible sources of bias. So there are 8 that are listed in the textbook. There could be more. This is not an exhaustive list, but it's a good place to start when you're considering whether or not a statistical study has bias. So the first is that correlation does not imply causation, which means that 2 things can be related without meaning that one thing caused the other. So for example, you might find that people who are taller have larger feet, but that doesn't mean that the taller you grow, that's causing your feet to grow as well. So those 2 things could be related without there being a cause. The second is you have reported results versus measured results. So for example, we could be talking about a study of college students and their alcohol consumption before driving a vehicle. There's a difference between maybe how much alcohol the college students would report that they had before they stepped into a vehicle versus if somebody was watching them drink and measuring their alcohol consumption in a situation where they were observing them. Those results might be a little bit different because if you were driving tipsy or something like that, you might not report numbers as accurately. So you might say, oh, I only had 1 drink or whatever, when in reality, if it was watched by someone else, it was more. So reported results versus measured results, there's going to be a difference there with your data. The next is small samples. So if I was taking course evaluations for a class of 25 people and only 3 people filled out the course evaluation, that's a very small sample to tell how good the course was and if it was effective and if the students felt like they learned from it. The next is loaded questions or leading questions. So the way that questions are phrased can make you feel like a specific answer needs to be the right one. So isn't it true that this, or some other type of phrasing. The next, question order. So sometimes questions are written in a specific order, whether that be that there's 5 questions as part of a study or whether that be the way the question is phrased, so that the person providing the information or giving the data that you're getting the data about, it would influence the way that they answer because you're kind of leading them to an answer in the way that you ask the questions. The next one is non-response. So this kind of goes along with voluntary response samples. In voluntary response samples, if you give a survey out to 100 people and only 30 people give it back, then you had 70 non-response, and you don't know what that says about the data because they didn't respond. The next is precise versus accurate numbers. So precise means detail. I think of this as decimal places. So you could say, I'm 18.169 years old, versus accurate. Accurate means true. So you might know the day that you were born and the time of day that you were born, and be able to make a mathematical computation that gives you 3 decimal places of precision. But that number may not be accurate because you haven't taken into account leap years, you haven't taken into account what is it called? Daylight savings time, things like that. So it might be more accurate to just say I'm 18 years old. Even though it's less precise, it has less detail, it's more accurate. So that's another thing to consider. And then last is percentages. Percentages can be tricky because they can hide information, like they can hide that you have a small sample size. So if I had 3 students that took a course evaluation and all 3 of them really loved the course, then I could say 100% of students appreciated this course, even though it really was only 3 out of a class of 25 that appreciated the course. So percentages can be tricky if you don't know what the percentage is representing. All right, so we're going to go through some examples just to see how to kind of analyze some of the data, some situations, and to recognize some places where bias might be happening. All right, so let's go ahead and look at these. So the first example says, researchers at Yale University conduct a wide variety of clinical trials by using subjects who volunteer after reading advertisements soliciting paid volunteers. Does this sampling method appear sound or flawed? So sound meaning it's a good sampling method, flawed meaning you're going to get some results, but they're not going to be representative of the true population that you're studying. So the issue here is that you're looking at subjects who volunteer. And so this is a voluntary response sample. And voluntary response samples are never representative of the population. I mean, it's possible, but very unlikely. So this is likely flawed. Okay, so not representative of the population. A couple other issues that you might see is that these people who volunteered read advertisements from researchers at Yale University. So unless they are trying to study a population of people who read advertisements from Yale University, then they're going to have a limited number of people that they're reaching. So they are limited to those who saw the advertisement and then also they have paid volunteers, and the pay adds incentive. And so you get a little bit more than if somebody just volunteered, but it's still not going to be an accurate representation of the population. Okay, let's look at a few more examples. In a survey of smartphone ownership, the Pew Research Center randomly selected 1,006 adults in the United States. Does this sampling method appear sound or flawed? So in this situation, that's a good amount. That's not a small sample, 1,006, okay, in the United States. And the answer here, is it sound or flawed? The answer is it depends. It depends on what you're trying to study. So if you are looking at adults in the United States and you want to know about their smartphone ownership, then you could say it's relatively sound. But if you're talking about all of the people who own smartphones in the United States, then you're discounting all the teenagers, all the children who own smartphones, and that's quite a few. So we're going to say it depends. On the population being considered in the study. If you're studying adults in the US, it's probably okay. Now, we're giving a lot of trust in when they say that they were randomly selected. We're trusting that they're coming from different demographics and socioeconomic backgrounds and belief systems and races and all sorts of things, so that nothing could have any sort of correlation there, impact there, that it's truly a random sample. But if this is what we're studying, we're good. Now, if they wanted to know all the people who use smartphones, then no, we're going to say that this is just adults. This doesn't include teenagers and children. If they're talking about adults who use cell phones, smartphones specifically, worldwide, that's not a good sample either. So it truly depends. In a USA Today online poll, 951 readers responded, and 57% of them said that they prefer drinking bottled water instead of tap water. Identify potential issues with this data. Okay, so one issue is that we've got USA Today in an online poll, so that's a very specific audience. There's a lot of people who aren't going to see this. Another issue is that we have readers who responded, so that's a voluntary response sample. So we've got a few issues here. We've got only available to USA Today readers, only available online because it was an online poll. And then you could be nitpicky and you could say, well, drinking bottled water is one way to drink water. Tap water is another way to drink water. But what about the people who drink filtered water? Would they be considered bottled water or tap water? Is it vague to not include that as an option? Should there have been 3 options instead of 2? So we're going to say only provided 2 options. What about filtered water? All right, for the next example, an electronic cigarette maker sponsored a poll showing that 55% of smokers surveyed say that they feel ostracized sometimes, often, or always. Identify any potential issues with this data. So I would go ahead and pause the video and see if you can come up with some things, and then play the video again and we'll see what we've got as a whole. Okay, so you might have noticed that this is sponsored by a company, so that's generally speaking, that's a red flag. If it's if it's sponsored by a company, especially a company that's going to be interested in the outcome specifically. So electronic cigarette maker polling smokers, clearly a direct correlation or a direct connection there. So that's something that we'd be interested in. So sponsored by cigarette maker. Okay. Anytime you have a poll, those are typically voluntary response samples. And remember that voluntary response samples typically have people responding with extremes. So extreme positive or extreme negative. Another problem with this is when you see sometimes, often, or always, words like this. So sometimes, often, always. These words are a little bit vague. They require some interpretation, which means that the responses that you're getting from people could be inconsistent. All right. The next example says, a dental rinse claims to reduce plaque on teeth by over 300%. Should this statement convince you to purchase the dental rinse, explain why or why not? So with this one, you have to kind of understand how percentages work. And the key here is the 300%. So your gut might say 300%, that's great. That's better than 100%. 100% is probably good. 300% is probably better. 300% does not make mathematical sense. So 100% of something is all of it. So if they said they reduced plaque on the teeth by 100%, then they would be saying they reduced all of the plaque on your teeth. When they're saying they reduced it by 300%, they're saying the plaque on your teeth is somehow tripled. That's how much they reduced. And that doesn't make mathematical sense. So we're going to say no, their claim is impossible. There's no data that could back that up. It's more likely that a dental rinse reduced 50% of the plaque, or 75% of the plaque, or something like that. Most of the plaque, but not all of it. But you can't reduce 3 times of the plaque because 2 times it isn't even there. All right, the next example says the Newport Chronicle ran a survey asking readers to call in their response to this question. Do you support the development of atomic weapons that could kill millions of innocent people? It was reported that 20 readers responded and that 87% said no, while 13% said yes. Identify at least 4 major flaws in this survey. So go ahead and pause the video, see what flaws you can come up with. Okay, so there's more than 4 flaws here. So I'll just list as many as I can think of. So first, this is for the Newport Chronicle. So this is only available to Newport Chronicle readers. If you want to have information represent a population, and that population being people who happen to read this newspaper, then great. But that's probably not what you're studying. You probably want to figure out what people in the United States feel, or what people in a certain town feel. So if you're looking at only one I'm assuming this is a newspaper, but it could be something else. But if you're looking at only one publication, then you're only going to get a representation from that publication, and that's the issue. They asked readers to call in their response. So this is a voluntary response survey. Well, voluntary response sample. And it's not even as simple as we put the survey in front of you and you just have to click something. You have to read about the survey or hear about the survey somehow, and then you have to actually call a phone number and call it in. So we're getting really extreme answers here, of course. The next is the phrasing of the question. So if they had said, do you support the development of atomic weapons? ? That question would have been fine. But there's a lot of bias in a question that says that could kill millions of innocent people. The way the question is phrased, they tell you how they want you to answer. So the phrasing of the question, that's another issue here. They had yes and no. 20 readers responded. That's a very small sample if you're studying responses of people in the United States. 20 readers, we're going to assume that probably more than 20 people read this newspaper. So, or this, I don't know, could be a magazine. So even not knowing how many people, how many readers it has, 20 in a sample is still small regardless. And then the last thing, this one is a little bit more subtle and you might not have noticed, but 87% and 13% don't make sense for 20 people. So if we look at this, this is going to be a little mini math reminder. I'm going to grab my calculator. 87% of 20 people is 0.87 times 20. So 17.4 people gave a response of no, while 2.6 people apparently said yes. So somehow they got their percentages from something else, but it wasn't saying that 17.4 out of 20 people said no and 2.6 out of 20 people said yes. Their data doesn't make sense. So those percentages came from somewhere else. And that's another flaw that we're seeing if we're analyzing the data from this survey. Okay, so now that we've analyzed the data, we're going to look at conclusions we can make. So we're going to determine the statistical and practical significance of the data. So now we're going to go back to the first page of our notes, those vocabulary terms. We have 2 more terms to complete. So statistically significant results are results that are unlikely to occur by chance. Results that are unlikely to occur by chance. Practically significant results are results that are considered worthwhile or effective. So when you conclude the process of your statistical study, you're going to ask yourself, is it statistically significant? Was it unlikely that it occurred by chance? And is it practically significant? Is that result worthwhile and effective? Okay, so we're going to look at 2 examples here. First, the medical college admissions test, the MCAT, is commonly used as a part of the decision-making process for determining which students to accept into medical schools. To test the effectiveness of the Siena MCAT preparation course, 16 students took the MCAT, completed the preparatory course, and then retook the MCAT. The average, the mean, score for this group rose from 25 to 30. There is a 0.3% chance of getting those results by chance. Are these results statistically significant and are they practically significant? So statistically significant means, are they unlikely to occur by chance? There's a 0.3% chance of getting those results by chance. So yes, they are unlikely to occur. Oh, I missed the O. Occur by chance. Those results are unlikely to occur by chance. If the scores rose from 25 to 30, it's definitely because they took that preparatory course. Are they practically significant? Here, context would have been really important. A score rising from 25 to 30, it's rising by 5 points. That could be significant if it was a score of 25 out of 30 and it became 30 out of 30. I went from, I don't know, what is that? 25 out of 30. I went from an 83% to 100%. That's super significant. But if it's scored out of 100, 25 out of 100 to 30 out of 100, that's not significant. That's not worthwhile. So it depends. So 25 out of 30 to 30 out of 30. Yes, that would be worthwhile. That would be effective. 25 out of 100 to 30 out of 100. No. So it depends. Okay. Next example. Most people have IQ scores between 70 and 130. IQ scores of 100 are considered normal or average. For $40, you can purchase a program that claims to increase your IQ score by 10 to 20 points. Suppose a study of 12 participants produced an average IQ increase of 3 points. There is a 25% chance of getting such results if the program has no effect. So you take the program, it doesn't work, but you still increase by 3 points just because you retook the test again. Are these results statistically significant? Are they practically significant? So statistically significant, we're going to say no. This is not something that you would have known before you took these notes, but the benchmark for significance is 5%. So that means that percentages larger than 5% aren't that unlikely. So if it had said there's a 6% chance of getting these results, that would not be statistically significant. If it said there's a 28% chance, that's not. If it said there's a 50% chance, that's not. If it said there was a 2% chance, then you'd say yes, that is statistically significant. So numbers that are less than 5, you'd say yes. Numbers that are greater than 5, you'd say nah, they're not that unlikely. That could have happened by chance. Okay, practically significant. Is it worth $40 to you? Pay $40 to rise by 3 points. So you had an IQ score of 110, now you have an IQ score of 113, and you paid $40 for it. Is that worth it to you? I'd say probably not. $40 for 3 points. Now, if it was going to raise by 20 points, if my IQ was 110 and it went to 130, okay, I'd pay $40 for that. But 3 points, maybe not so much.